Hey class, so today we are starting our first official unit, which is all about functions. This is actually Miss Leslie's least favorite unit because it's very boring. A lot of this is going to be just kind of getting into what are functions, which different types of functions are we going to be studying primarily this year, the parts of functions. Really, it's a lot of vocabulary, a lot of just kind of different skills that we're gonna look at. There's not a lot of like what I would say like is heavy algebra. All right, so some people find this unit to be really easy. People find this unit to be really boring, therefore they don't do a lot of stuff and therefore they do badly. Even though the stuff that we're going to talk about is all stuff that you should know, depending on how well you paid attention in previous math classes, but it can be a bit dry. All right, today specifically, we're looking at a lot of terminology. We're going to look at different definitions for functions, different parts of them, that kind of thing. So bear with me. This, like I said, is not Miss Leslie's favorite unit, so we're just going to get through it together. It's okay. It's a short unit. It's only 6 days, which I guess this year is 3 weeks, but we're just going to pretend 6 days. Anybody can do something for 6 days. It's no big deal. All right. So here we go. We are starting our first official unit, which is kind of exciting. All right, let's go. All right, I gotta scooch over. So today, like I said, we are just doing an intro to functions. We're hitting some basic terminology, some that we've already talked about, some that we haven't. But you should have seen all of this terminology, hopefully in previous math classes. So it should be kind of a nice little review for you. Okay, so let's start by talking about what is a function. So in a lot of math classes, you hear this term function tossed around all the time, but I'm not really sure if everybody actually knows what it means to be a function. This is definitely something you would have learned in maybe a pre-algebra or like maybe algebra 1. But basically, when we say something is a function, we mean that it's a special relationship where for each x, you have only one y value. That's it. That's what we mean by function. All right, so what is a function? All right, it's a relation, fancy math word. So a relation where each x has one unique y value. All right, so for each x, there's only one y value. All right, now functions also have their own notation. We call it function notation. And this is that fancy f of x that you see in front of equations sometimes. Basically what that is just a label. All right, so you go to a store to buy shoes, you walk in, and if you see a shoe that has that little like swoosh on it, you know it's a Nike shoe, right? Because that's the brand for Nike, is that little doo-doo, whatever, right? Function notation is the same thing. So if you see something f of x, then you know, oh, that is a function. That's all it means. Doesn't do anything cool. Some people really don't like the f of x. They think it's weird, but it's just a label stating that this equation is a function. All right, so I like to think of this as like a label, right? It's like branding for equations or whatever. Okay. Now, there are a couple ways that you can determine if a relation or an equation is a function. The first is to look at its table values. All right, so remember we said that for each x, you can only have one y value, all right, which means that the same x can't have two different values for y. Now, you can repeat y values, all right, but you can't have, basically we're looking for anytime we repeat x values, all right, so let's just look at a set of numbers. So let's say we have 0, 0, 4, 7, 3, 6, 4, 2, 8, 1. Okay, So it's just a list of points. All right. You could also see it in a table, right? We know XY tables, right? Look like this, XY. And you would just have like a 0, 0, 4, 7, 3, 6. Da, da, da. You guys get the idea. All right. So you can either have your points listed or you can have them in kind of like a table view. So what we're looking for is we're looking for our, sorry, lost my train of thought. What we're looking for is for any of our points to repeat x values. Like we're looking for the same x value to happen more than once, because that means that this x value has two y values. All right, so all we do is go through and we basically just kind of highlight all of our x's. All right, now if all of these x values are unique, like we don't repeat any of them, that means that this would be a function. But however, in this problem, you can see that we do repeat x's. We have two x's that are the same. That means for the value x equals 4, if you plug in 4 into an equation, you're going to get two different y values. That is a red flag. That means not a function. All right, now you can repeat y values though. So if I were to switch these points up and maybe I had all the x's were different, but maybe I repeated one of the y values. Well, that's still a function. You can have the same y value more than once. We actually have that in our quadratic function, right? When we make that nice parabola shape, you repeat y values all the time, right? Y values are your height of your function, and that's okay. You just can't repeat x values. All right, so graphically, this is probably the fastest way to do this, and most people have heard of this technique before. So graphically, what you're going to do, so if you have your equation graphed, you're going to perform what's called the vertical line test, which means if you run like a pencil or a vertical line, right, vertical up and down, across your paper, across your graph, if it crosses that pencil more than once, it's not a function, because that means you've repeated your x values, right? And we don't want to do that. So graphically, you want your graph, all right? Looking for the graph, looking for graph to pass a vertical line test, right? So let's just sketch a little. I don't have a lot of room here, but that's okay. It doesn't have to be beautiful. All right, so here's our graph, right? So say we have like blue, whatever. All right, if we were to like take our pencil, right? Take any kind of vertical line, right? This is just our fake line that we're kind of drawing. And I were to just move this across the graph, if this is a function, it will only ever touch that blue line. It will only ever cross one time every time that I kind of move my pencil, right? So this actually is a function, right? But this would be not a function, right? So if I had something like this, and I drew my graph and I went like this, right? And I were to draw a vertical line, see how it crosses? It crosses here, here, and here, right? 3 places. This is definitely not a function. All right, so this is a function. Check. This is not function. No. All right, so those are your two kind of easy checks to figure out if something is going to be a function or not. All right, now moving on to domain and range. All right, we talked about domain and range a little bit in our review unit, but I just want to make sure we go over it a little bit more now, because it is very important to functions knowing their domain and range. All right, so domain. These are your possible x values for your function. All right, we call these the input values because these are what we're putting into the function, all right, to get some kind of result. All right, so domain, these are our input values, right? There are x's, x values. Now, when we're writing our domain, all right, the easiest thing to do to figure out what your domain is going to be for your function. I know when we did our review unit, we had just quadratic. So we said the domain was all real numbers because you can plug in any x value into a quadratic and you can get some kind of y value. All right, but not all functions have that all real number domain. So the easiest way to figure out like values that are going to get excluded from your domain is to ask yourself, what can x not be? All right, and that's really the easiest way to do that. All right, so you're looking for, so to exclude values, ask, right, what can x not be? Right, that's how I always think of it. Like, what can I not plug in for x? All right, and some of them are pretty easy to figure out. So for instance, if you have this square root function, right? So we'll just kind of think of our square root function. So we have the square root of x, just basic, right? What do we know can't happen underneath a square root? Well, we can't have a negative number under a square root, right? If you have a negative number under a square root, we know that that means it's an imaginary number and it doesn't have the ability to be graphed, right? We talked about that when we did our quadratic formula. If you have an imaginary value for x, right, that means it doesn't cross the x-axis. You can't graph that. All right, so we know that x has to be larger than 0. It can also be 0. You can take the square root of 0. So we'll say it has to be equal to 0 and then larger. All right, can't be negative. Well, those would be values that we would be excluding from our domain, anything that's negative. All right, and we're going to come back to that in a second because we're going to use that as our example when we do interval notation, because this is important to talk about interval notation also. All right, so I'm just going to write it right here. We know that x has to be greater than or equal to 0. All right, if it's negative, it won't work. Okay, so that's domain. All right, pretty much this is the easiest one to figure out. Range is a little bit more complicated, so I'm moving on to range. All right, so range is your output values. All right, it's what you get out of the function once you put your x values in. All right, so these are your y values. All right, now there's two real ways to figure out what the range is going to be. The first way is probably the technique that most people are going to use. All right, so that would be to graph and look. All right, simple as that. All right, so graph and you want to look for y values. All right, it's usually pretty obvious when you have y values that are not going to be included, right? Just like your quadratic, right? When we graph our quadratic, we see that there are parts of the graph that our quadratic just doesn't cover, right? And usually those are whatever's below the vertex, or if your quadratic is flipped upside down, whatever's above the vertex. All right, but there is a second way to kind of figure this out. All right, so the second way to determine the range, and like I said, this is nobody's favorite method, but some people do like to look at things more algebraically rather than graphically. I'm one of those people that kind of graphs sometimes confuse me, so I like to just do it with numbers instead. All right, so that second way is going to be definitely more algebraic. The range is also the domain of the inverse. All right, so if you were to find the inverse of a function, all right, now some of you remember how to do this, some of you don't. We actually will go into inverses later on in this unit, all right, but if you remember how to do it, you can always find the inverse of whatever function you're working with and then find its domain, because that will be the range of your original function. And just really quick, because like I said, we're going to do a whole day on inverses, but just a brief, like, remember this, you did this last year in algebra 2. It's when you flip the x and y's and then solve for y. That's how you find the inverse equation. Some teachers teach it differently, but that's like the gist of it. My recommendation is that unless you really hate graphing, just look at the graph. All right, so plug it into your calculator, plug it into Desmos, whatever tool that you're using for graphing right now, use that. Look at and see what y values happen. If you want to be really, really kind of extra careful, I guess, you can do the second option. We'll talk about it more when we actually get to inverses, but it is actually one way to figure it out. Okay, so interval notation. All right, we talked about this also. All right, this is how we are going to write domain and range in this class, is by using interval notation. All right, so how we express domain and range. Okay, so we talked about it. It's always going to be either a parentheses or a bracket, smallest number, comma, largest number, and then either a parentheses or a bracket. All right, and then just to remind you, a parentheses is used for numbers that we're not specifically including in our graph, but that we're getting really close to. All right, so not included, but we get close to it. Okay, whereas a bracket, these are values that we are including in our graph. All right, so when we did this with quadratics, your vertex value for your y ended up being a bracket point because it was included in your graph, right? You touched that point, but you didn't go below it, right? Whereas we would do like infinity always gets a parentheses because your graph will never actually touch infinity because it's not real. It's going to get close to infinity, the concept of infinity anyways, but it's never actually going to like land on that point. All right, so these are included. All right, the last piece of interval notation we need to talk about is when you have more than one piece to your domain or range, and that happens sometimes. Maybe you just skip a point. This happens a lot with rational functions, right? Those are the functions that have a fraction with the x on top and bottom or whatever. Sometimes we have what's called a hole in our graph, and so you kind of have to skip over a point. That is going to then break your domain or range up into two parts. If you have a two-part domain and range, the symbol for that is just a little U. It stands for the union. All right, so we have this symbol. Like I said, it looks like a U. This just connects pieces of domain and range. Right, so if you have multiples, okay, so like say your domain or range goes from like negative infinity to 1, and then it was like, hold up, wait a second, we don't have that point. And then right after you go past 1, it starts up again. You would need two pieces, and you would use a U to connect them. We'll look at some examples. Okay, so here we go. Determine the domain and range of the following functions. All right, let's scroll up a little bit. There we go. Okay. So first one, we have a rational function like I was just talking about. So we want to look at this, and we want to first ask ourselves, what can x not be? So we're doing our domain first. All right. So in a function like this, all right, the 3x is really just like a linear piece. If you ignore the bottom of the function, 3x is easy. Any x can be anything up there. All right, but hopefully you guys remember what happens in the bottom of fractions that we can't have. What can't we have in the bottom of a fraction? Well, math law says you can never divide by 0. So we have to exclude any x value that would give us a 0 in our denominator. All right, so can't divide by 0. All right, so we're going to figure out, when is x minus 1 going to be equal to 0? Well, that's when x equals 1. All right, now this is actually one of those special cases where we have something called an asymptote. All right, hopefully you guys remember that word. If not, we'll definitely talk about it in a second. All right, so if you don't know what this looks like, if you don't know if we're skipping just over it a little bit, or like what's happening here, you can definitely graph it, because we are going to have to graph it to do our range anyways. All right, but what we need right now is just to know that x cannot equal 1. All right, and that's the only thing that x can't equal, right? Any other number we want to plug in for x is fair game, just not 1. So to write that, we would do it like this. All right, so remember, it's always smallest to largest. So smallest number is always negative infinity. In parentheses, because we don't include negative infinity. All right, and then we go all the way to 1. But we can't include 1. We don't touch 1. All right, so parentheses, all right, because we cannot touch that 1. All right, now after 1 is over, we have all the rest of the numbers. So we're going to start back up again at 1. Once we kind of pass it, we're like jumping over it, and we're going to keep going all the way to positive infinity. And to connect these two, like I said, we're going to use a U, stands for the word union, the union of these two intervals, all right, to express our domain. So this is the domain of our function, all right? So we go up to 1, jump over it, and then continue going. That's what this is saying. Okay, so let's do range. All right, so these are y values. All right, so we're just going to look at the graph. So I'm going to go ahead and I'm going to sketch this graph. All right, I'm going to use my calculator. So 3x divided by x minus 1 graph. All right, so I'm just going to, like I said, graphically, we're going to do this. So my function looks something like this. So right here at 1, it goes like that. And then it also goes like this. All right, now, if you remember anything last year from rational functions, I know you guys didn't cover it in great detail because we were doing coronavirus at that point. All right, you will remember that asymptotes look kind of like this, right? They're like, we draw them as like dotted lines. Well, this right here, that's the asymptote when x equals 0. So it's a line we're not going to cross. All right. We also, if you look at it, there's a horizontal line right here that we're also not going to cross. All right. And you would use your table function to figure out what that is, or you can kind of just zoom in on your graph if you want. We're going to go more in depth with this in future units on how to find all these pieces of a rational function. But for now, using your calculator, you can really pretty much get a good estimate of what's happening. You can also look at your table values and notice what are your y values getting close to but never actually touching. And for this problem, it's 3. So that line right there that we're not kind of going to cross with our graph, that horizontal one, is at y equals 3. So we're excluding that value from our range. Everything else is fine, right? You can see that one side goes up for forever, the other side goes down for forever. It's just that middle piece right there where we're kind of, looks like we're skipping over it, right? And so we would say y cannot equal 3, all right, based on the graph. Okay, so we want to make a range that indicates that. Well, technique is very similar to domain. We're going to start with the smallest y value, which is always negative infinity. All right, and then if we're moving up our graph, we go up until we get to that line of 3, and then we stop. We do not include 3, right? That's not going to be part of our graph. We're going to close that parentheses. But then, right, once we get past 3, so like right here, once we get past 3, it's going to keep going up for forever. So we would say 3 then to positive infinity, and that's our range. All right, so kind of weird, right? But not too bad. Let's look at a second one just to kind of make sure we're feeling okay. And that'll be the last thing for this video. We're going to get into end behavior limits and asymptotes in the next video, but this one's getting up there in time and I don't want you to have to watch a super long video. Okay, so here we go. First thing for domain, we need to figure out what can x not be. All right, well, we talked about this before. We said that x, we can't have negative numbers underneath a square root. So no negative numbers under square root, right? So we need to figure out when is this stuff underneath the square root going to be a negative. So what we're going to do is we're going to take x minus 4, and we know that it has to be greater than or equal to 0. Has to be 0 or bigger. All right, and we're just going to solve this. So that gives us x has to be greater than or equal to 4, right? We're just going to add 4 to both sides. All right, so x can be 4, right? If I plug 4 in for x, that gives me 4 minus 4 square root of 0, which is okay. There is a such thing as square root of 0. It's 0. But if it's anything smaller than that, right? If I were to plug a 3 in for x, well, 3 minus 4 is negative 1. Error, that's an imaginary number, so we can't have that. So our domain, x is greater than or equal to 4. All right, so if we're writing this in our interval notation, smallest number it can be is 4, comma, biggest number it can be is infinity. You never include infinity, so it gets a parentheses, but since we are allowed to have 4 is an okay number to plug in, we're going to use a bracket. All right, it doesn't go below 4, so we don't have to worry about doing a 2-part domain here. All right, it just starts at 4 and goes on. So that's it. That's our domain. Awesome. All right, let's check out the range. So for range, again, I'm going to go ahead and I'm going to graph this function. Hopefully that's what you guys are doing also. So square root of x minus 4, graph. All right, and this, so here's my little boop, boop, boo, doo, boop. Hope you guys like my sound effects. All right, we have right here, and then it goes like this. All right, so if this is my graph, this one's kind of nice, right? Remember, for range, we're looking at y values. So down here, right, below the x-axis, I don't have any y values. It's not going to go below there, right? I'm never going to get a negative value out of this equation. It's not possible. It's not going to happen, right? So I know that I don't have any negative values. My first y value starts right here where it touches the x-axis, which is a y value of 0. So I know that I'm going to start at 0. So y is going to be greater than or equal to 0, right? But we have to change this to interval notation. Okay, so it's going to look really similar to our domain, except instead of 4, we're going to use 0. Our smallest number is 0, comma, our largest number will be positive infinity because it is going to keep going up, even though I know it's kind of curved. All right, we don't include infinity, but we do touch the value of 0. So that gets a bracket. That is the range of function number 2. All right, so like I said, I'm going to stop this video here because we are already at 28 minutes. At least you didn't have to sit through it in class. At least hopefully you're on your couch in like comfy clothes or something. But yeah, so we're gonna stop. Hopefully this helps you guys kind of understand basic terminology, and the next video we'll get into talking about end behavior limits and asymptotes. Bye guys.